Welcome to physics.
In this WOW physics lesson, you will learn about fluid mechanics. What is fluid mechanics? Fluid mechanics is the study of the effects of forces and energy on liquids and gases.
First of all, we must have a knowledge about density and pressure.
What is density? Density tells us how pure the object or the substance is. Density equals the mass of the substance divided by its volume. The SI unit of density is kilogram per cubic meter. The more mass and less air on the object has, the more dense it is. Let us proceed in pressure.
What is pressure and fluid mechanics? Pressure is a measurement of the force per unit area. Fluid pressure can be caused by gravity, acceleration, or forces in a closed container. Fluid pressure or the uniform fluid density, where pressure at depth from the reference line is equal to the pressure at the reference line plus the density multiplied by the gravitational acceleration and the depth from the reference line. The SI units of pressure are Newton per meter squared, that can be also defined as the Pascal.
Under the fluid mechanics, each three honorable persons gave a contribution. The first one is Pascal's law. Secondly, the Archimedes principle, and the last one is the Bernoulli's principle.
Pascal's law states that when there is an increase in pressure at any point in a confined fluid, there is an equal increase at every other point in the container. Moreover, the formulas that relate to this are shown below since the pressures are equal throughout. Since pressure equals force per unit area, then it follows that Archimedes' principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body displaces and acts in the upward direction at the center of mass of the displaced fluid. The weight of the displaced fluid is directly proportional to the volume of the displaced fluid, if the surrounding fluid is of uniform density. Archimedes determined that a body which is completely or partially submerged in a fluid experiences an upward force called the buoyant force, B, which is equal in magnitude to the weight of the fluid displaced by the object. Moreover, here is the formula for buoyant force. Bernoulli's principle thus says that a rise, fall, in pressure in a flowing fluid must always be accompanied by a decrease, increase, in the speed, and conversely, if an increase, decrease, in the speed of the fluid results in a decrease, increase, in the pressure. The Bernoulli equation can be considered to be a statement of the conservation of energy principle appropriate for flowing fluids. The qualitative behavior that is usually labeled with the term Bernoulli effect is the lowering of fluid pressure in regions where the flow velocity is increased.
Say that some water flows through an S-shaped pipe. At one end, the water in the pipe has a pressure of 150,000 Pascal, a speed of 5 meters per second, and a height of 0 meters. At the other end, the speed of the water is 10 meters per second, and the height is now 2 meters. Since the density of water is 1,000 kilogram per cubic meter, all you're missing is the pressure at the second point, and this can be determined by rearranging Bernoulli's equation to get it alone on one side.
Created using Powtoon.